answer sheets and today's information sheet on your way in. We're going to spend about 5 minutes where you can just compare the answer sheet to your homework. Okay? I'll give you a little tour of the answer sheet. This one is the page 44, which is 36 through 52. Okay. This is the even answers right here. This is the even answers for page 53. 5, 21 through 25, 42, 43. And then this is the two. This is not on yours. I apologize, but I did not put this on your sheet. This is the A and B problems that I asked you to graph last night to continue increasing your piecewise function skills. So there's a lot to do. I want you to do a good job with it. So take 5 minutes. If you do a good job, it should take a little bit. Really happy with yesterday. If we keep it up, we got something different we'll do on Friday. I think you guys will like. My ask is it for your effort. Get after it.
I want these answer sheets put back.
Riley, you read my mind. If you're done with the answer sheets, I do want them put back up here, but no hurry. Yes, you definitely keep that other deal with all the F of, and G of, and all that good stuff. Again, no hurry. What? Yes. Save you some steps. Is it worth my time writing those out or not? I think the biggest thing that it helps is it just helps you grade things quicker, and it actually helps me emphasize a couple different things that I think are important. So, for example, I think it is very important that when you're doing things like 56 and 57, all that good stuff, that you label your axis. Like C and P, or use variables that make sense. I'm not a big X and Y fan. Because X, what does it stand for? Unless you got a problem that's dealing with like X-ray machines or something like that, well then you can use X. But if I'm dealing with cookies, or chocolate chip cookies and peanut butter cookies, you'll need that other sheet. You'll need that sheet. Yes, we're not done with that. Okay. Also, I want to talk about 59 real quick. If I zoom in on 59, I want you to understand the importance of good, accurate graphs. First of all, I like to find both my intercepts and then I can choose my scale. And this one I went by tens because I know I'm going to have a 70 and a 40. I can fit that in. Okay. And then they asked you on 59 to come up with 4 other points that would earn that much money or more. Okay? So how did I come up with these points? I just read my graph. If I do long sleeve, actually, I just flip-flopped. It should be short sleeve, long sleeve. If I do short sleeve, long sleeve, 70 short, 10 long would be fine. Why? Because it's in my shaded region. 0 and 50, 0 short sleeves, 50 long sleeve would be fine because it's in my shaded region. So in that case, in these cases, we're showing what will work. Then you can read your graph to find out what combinations of sales for short sleeve and long sleeve will work. These problems are nice and straightforward if you just have your graph somewhat accurate. So like here, 40 and 30. 40 of these, 30 of these. Yep, that point's right there. So yeah, it's in my successful region. Okay, it's going to make enough money. 50 and 20. 50, 20. Yeah, that's right there. That's in my successful region. So yeah, that's going to make enough money. Okay. 60, I got to tell you, I did not like 60. I did not like 60 at all. Because we're working with some stuff that might be a challenge for people, and they're playing around with your variables in ways I don't like. Scented candles, hand soaps. Like, they started talking about scented candles, so I used an S. But later on, they just started saying candles. And it confused me. I don't know if it confused you at all, but it did me. And like this one, hand soaps. So soap, scented, I don't know, it just drove me crazy. So I started using 2 different variables, a more descriptive variable, to help me understand it more. I thought that was a poor choice on their part. So anyway, on the back side of this, I wanted to point out a couple things real fast. If I'm looking, where am I at here? I'm so zoomed in, I can't find myself. It's kind of like in a video game when you get turned upside down. Okay. Like in this one right here. You'll notice that the numbers were so huge, I scaled my axis by 2s. 2, 10, 20. I always put 10 and 20 to keep my orientation so I don't have to count from 0 all the time. But the reason why I put a question mark here is I want you guys to think about this situation. I've got a 2x, so my slope is 2. But look at what I did. I just went down 1 over 1, but my slope was 2. Why did I do that? Well, what's 1 block worth in this problem? 1 block is worth 2. So go down your values, not just blocks. Okay? So if I want to go down 2 over 1, don't go 2 blocks over 1 block. Go down 2 units, which is just 1 block in this case. That's something to keep an eye open for. You can scale things, but then when you scale things, you can't just count blocks. You got to think about what each block represents and then make your changes accordingly. Okay? 21, 23, 25, they're in the back of the book. Okay? So I encourage you guys to look back there. Let's look at your worksheet real quick, and then we'll answer any questions you have. What did the boy tree say to the girl tree? I pine for you. Okay? To pine for something or somebody means to want, to desire. Okay? I pine for you means I have a deep, often sad longing or desire for you. Okay? So the boy tree is saying to the girl tree, I want to spend time with you. But why is this supposed to be kind of different? Pine is a type of tree. A fir is a type of tree. And a yew is a type of tree. Those are all three types of trees. Okay. What was the hardest problem on this worksheet? Which one? What was the hardest graph? What do you think? No opinions out there? They were all equally easy? 6? I would say 6 is the hardest problem. Okay? Because you got going in a rhythm, finding my x-intercept, finding my y-intercept, finding my x-intercept, finding my y-intercept, and on 6, you find your x-intercept is 0 and your y-intercept is 0. It's the same point. So then how do you find another point? Okay? Well, in this case, there's 2 ways you could skin this cat. Yeah. You could either get y by itself, and your slope is negative 1/4. So down 1 over 4. That would work. Because your goal is to get another point. Another thing you could do is you could just play around. Okay, if I plug in 4 here, this would have to be negative 1, and then I'd get the point 4, negative 1 that I could plot. But then we run into another problem. Since 0, 0 is on my line, can I use 0, 0 as my test point? No, I can't. Okay? I can't look at the fence and say which side is greener. I got to look at one side or the other. So what you could do is you could pick any point besides 0, 0, like 2, 2. If you pick 2, 2, 2 plus 4 times 2 is greater than 0. They give me 10 is greater than 0. So yes, that is true. Okay? So that one, you kind of got to think, okay, I got to scramble. How can I get this done? How can I get this done? And then figure it out. Okay. Any of these problems you want to take a look at? Anything? Let's make it quick. I don't want to sit here and look at you guys for 5 minutes and not ask questions. I'd rather have you guys ask a question or two. If not, we'll move on. $56. Is that okay? This one right here? Okay. On 56, it says that they want to charge $1.25 for a chocolate chip cookie, $1 for a peanut butter cookie, and make at least $25. Okay? So honestly, I think this equation kind of writes itself. 1.25 for chocolate chip, $1 for peanut butter. I want to make at least $25. Where am I coming up with these points? This one, this is 25, because if I just sell nothing but peanut butter cookies, I need to sell 25 of them to meet my goal. Bless you. If I sell nothing but if I don't sell any peanut butter and just all chocolate chip, I got to decide how many chocolate chip I'm going to sell. So I divide by 1.25. And that gives me 20. So hence, that's where my graph comes from. I should not have shaded in here, hence the oops. Okay? So these are all the combinations of things I could have chosen or could have sold and meet my goal of $25. Okay? C, my graph would have changed like this. Why? I didn't write my equation, but I definitely could have. 1.5c plus 1p is greater than 25. It just changes my c-intercept. And now there's a point like 18 chocolate chip cookies would have been enough, where before it wouldn't have been. And then part C, if I wanted to make $50, everything's just going to be twice as far out. Because I'm going to have to sell twice as many peanut butter, twice as many chocolate chip. Okay? And if I wanted to sell less than that, this is what part D was asking, I would have to shade the other way. Okay. Hopefully that clarifies that a little bit. Anything else before we move on to our other little sheet? Okay. Couple things. Here we go. This, in my opinion, is a fundamental skill. This will definitely be on a quiz, and it's not in the book. Oh, and by the way, I wanted to take just a second and tell you that after visiting with administration and stuff like that, we're just going to do some things different than the book. The book is not our gospel. The book is a guide for us with some resources. I just want to tell you that in this section, they're graphing absolute values. We're not going to do that in this section. We're going to do that at a different time. Okay? It doesn't make sense here. We're going to do it later. Okay? Same thing with this symbol right here. That's the greatest integer function. We're going to do that at another time. Our plate is beyond full already with piecewise functions. So the reason why I tell you this is if you go back and are studying and are trying to get ready for this test that we'll have probably at the end of next week, and you're like, I don't remember graphing these absolute values, I don't know how to do them. That's right, because we didn't do them. Okay? So just realize we're just going to go and put that aside. Okay? There's a better way to do it and a better place to do it. Okay. Okay, piecewise functions. I'm going to do one last thing with it, and then we're just going to practice it for a couple days, and then we'll be good to go. We'll do like one graph a day next week or something like that. Here's what I want you to understand. Don't write any of this down. But functions are like a machine. Okay? If this function, if I put in x, I'm just making something up here. Okay? This might be like the 2 times x plus 5 function. Okay? If I drop, like, say, 4 in there, what do I get out? 13. So it spits out 13. Okay, that's a function. We just go ahead and put something in, the machine goes times 2 plus 5, and we get out 13. Okay? Piecewise functions are a different monster. Okay? If I would take a look at a piecewise function, you don't know which one it's going to plug in. It's all based upon what value you plug in. Like this first one. I'm going to kind of transfer this down here. This one says if x is less than or equal to negative 2, I'm going to plug it into 2x plus 1. Okay, because that's what it's saying right here. Okay, and did I start this recording? I think I did. I just want to double check. Yes, I did. Good deal. Okay. The next one says if it's negative 2 is less than x is less than or equal to 3, my answer is going to be 3. Next one says if x is greater than 3, then my answer is going to be negative x minus 4. That's kind of a sorting mechanism. Okay. So if I put in a value, it's got to check what my value is first, and then it's going to sift it into the right thing. It's kind of like if you're dumping coin. You ever seen that deal in Walmart where you bring in your coins and it gives you a Walmart card of that value? Well, it's sorting your coins. So this is kind of sorting, okay, my x belongs in this one, so my answer is 3. My x belongs in this one, so I'm going to take the opposite of it, minus 4. My x belongs in this one, so I'm going to get 2x I'm going to plug it into 2x plus 1. So what we're going to do is we're going to practice that a little bit, and we're going to come up here. So now we're to the top here. If I go f of 1, we have a decision to make. Am I going to plug it into equation 1, 2, or 3? The first one, the second one, or the third one? Second one. Why? Because 1 doesn't satisfy that condition. It doesn't satisfy the last condition. It satisfies this condition. It says, yeah, if it's in this range, then I'm going to plug it into this, which there's nothing to plug in. My answer is just 3. So what we've got to decide on each thing is if I input a number, I got to figure out which condition it satisfies, which one I'm going to plug it into, and then I'll get my answer. Okay? If I plug in 5, which one do I use? The first one, the second one, or the third one? Go on, help me out. Third one. Okay? Because 5, nope. 5 is bigger than 3. So I'm going to plug 5 into this. What do we get? Yeah, negative 9. I should be able to do that off the top of your head. Okay? The opposite of 5, minus 4. So negative 5 minus 4. F of negative 6, help me out. Are we going to plug it into the first one, the second one, or the third one? First one. Because negative 6 satisfies this condition. Yep, less than or equal to negative 2. So, when I plug that in, what do I get? Negative 11. Why? Because 2 times negative 6 gives me negative 12, plus 1 is going to give me negative 11. Do the next 3 on your own, please. And if you get done before other people, you can go ahead and compare your answers. Excuse me. I'm trying to figure out where my microphone is on this thing. What if it's going through my computer, or is it going through this thing? Probably my computer. Okay, if you get done, compare with those around you. So we got to make a decision. Which one do we plug it into? And then carefully plug it in. Yeah, I want to see you comparing to your neighbors. Yeah, I like the talk I'm seeing. That's good. Okay, so here we go. Negative 2, does that fit the first, second, or third category? Negative 2. Help me out. Come on. First. So 2 times negative 2 is negative 3, or negative 4. And then I add 1, I get negative 3. Say, yep, if you got that. Yep. F of 3 fits this category. So my answer is just simply 3. I know it's weird. There's no place to plug in an X. Our answer is always 3. I could have put cow there, and my answer would have been cow. F of negative 10 fits this one. So 2 times negative 10 is negative 20, plus 1 gives me negative 19. Okay, the next one I'm giving you a couple functions that we haven't really worked with yet, but you guys have done this before. Absolute value of x. What's that? Absolute value of x takes what kind of numbers and changes them? Takes negative numbers and makes them positive. What does it do to positive numbers? Stays the same. Okay? The opposite of x, remember this is the opposite of x, not just, it doesn't make it negative, it makes it the opposite, and then squaring is times itself. Go ahead, try those 6. Yeah.
Like x
Less than negative 3. Yeah, I kind of changed my mind as I was going. And, yep, that is a negative 3. Thank you. I'll give you another 2 minutes to do it, and then if you have some time, check it with your neighbor. This is the powerful part. Check it, check it, check it, check it, check it. I put a trick question in there, by the way. I don't know if you caught it or not. Trying to make you think a little bit. Did you catch it? And the reason why we don't know, it's not in our domain. It's not in our defined domain. Yeah, undefined or unknown, don't know, I have no clue. You didn't tell us. Whatever. Okay, here we go. First one's negative 1. That's going to be a commonly missed one just because of this formula. You're going to plug it in right here. The opposite of what we plug in. If you had negative 3, you didn't do the opposite of what we plugged in. You just did negative 1 minus 2. Opposite of what we plugged in is 1. Minus 2 gives me negative 1. 3 gives me 10, because if I plug in 3 right here, I square it and add 1, give me 10. Negative 4, whoo, that's in this area. Opposite value of negative 4 is 4. 1, if I plug in 1, the opposite of 1 minus 2 is negative 3. What about 2? Did I tell you how to do 2? 2 is not anywhere found in that definition. So this is where you don't know. It's not in my domain. It's not something that we know how to calculate because they didn't tell us. So this would be no idea. You didn't tell us what to do. Okay? And the last one, negative 3, it's just the absolute value gives me 3. Okay. This skill will be on a quiz. Will be on a quiz on the next test or whatever we call it. Okay? Okay, there's one other, we're catching up on a lot of stuff here today. There's one other problem that we went back and that we actually never really had a chance to talk about in class. Number 5. The boxes problem. So I'm going to write this out real quick, and then I'm going to talk about it. Honestly, I think these kind of write themselves, but there's one particular thing I want to talk about. Okay? $48 for each box. If I'm doing from 0 to 3. 45 from 4 to 8. 9 to 19. And then 20, 42, and 38. Okay? Okay. There's only one thing I need to add here. Well, first of all, I think that's just writing in math language what that paragraph says. I think that's pretty straightforward. A couple things you'll notice is, what about 3.5? 3.5 isn't defined? Well, because they don't want to sell you 3.5 boxes. You're going to have to buy 4 boxes. So if you saw some gaps here, that's why. B would have to be a natural number here where 1, 2, 3, 4, 5, 6, no decimals. But if I'm looking at total cost, I need to take $48 times how many boxes? Like if I bought 2 boxes, you guys would all tell me, it's 48 times 2. If I'd buy 7 boxes, you would tell me it's 45 times 7. And it's 42 times the number of boxes and 38 times the number of boxes. So technically that is our function if we're looking at total cost. Total cost. Okay? Would you guys agree with me that that's a lot easier than graphing piecewise functions? Yeah, I think these kind of write itself. Okay? But I do want to do number 6 here real quick. Well, yeah. Because there's just one thing I want to talk about. There's a reason why I'm doing this, okay? I'm going to do all the tough work, but I'm just going to go ahead. 50 cents for each booklet. So I'm just reading and going 45 cents for every booklet. Okay. 40 cents for every booklet. And then I've got more than 250, 251. It's 35 cents. But then they throw in this deal about shipping. So this right here is the cost of the booklets. If I buy 10 booklets, I take 50 cents times 10, and it's $5. Here, if I buy 75, I take that times 0.45. That's my cost. But they say each order consists of a $10 shipping charge. So what do we have to do to these? Add 10, because it's going to add $10 for me. So that's my cost of the booklets, plus $10 shipping, plus $10 shipping, plus $10 shipping, plus $10 shipping. That's what number 6 would look like. Okay, because it's just coming up with a cost. But then I'm going to ask you a question, and this is something that coaches have to worry about. And hopefully it should make sense. Based upon these breakpoints and the costs, can anybody give me a number of booklets that would really be unwise to order? Yeah.
2.
2, okay. Yeah, 2, and it would, yeah, because the shipping would be most of your booklets. That's true. Okay? But beyond the shipping,
100.
Why would 100 be dumb? Yes, I could buy 101 and get it cheaper. Because if we would calculate it, okay, if I would do 45 cents, so 45, so if I do 100, my cost would be $55. But if I would do 101, so 40 times 101 equals plus 10, oh, clear. 40 times 101 equals plus 10. Okay, I'm making a mistake here. 100, it'd be, 45 times 100. It'd be 4510 is what that would be. 101 would be $4,050. Why? Because your price per unit just dropped a ton. So that's why, well, actually, when your coaches order t-shirts, they're going to say, if you order from 0 to 12, here's the cost. If you order from 13 to 24, here's the cost. If you buy 25 to 36, here's the cost. So a lot of times, if you have an order for 23, probably going to be smarter to order 25. Because you'll get to that next break point where it's cheaper. Okay? So, today I wanted to give you at least 10 minutes, and that's what's going to happen. We are right here. let me talk about this as I write it down. 53, 11, and 12 are just like the problems we just did with the writing functionals. Those will go pretty quick. And same thing with 37. I think this first page is going to go really quickly for you. 37 through 49 odd, those are graphs and potential shading. So you might want some graph paper for that.